Good morning, good evening, good afternoon, whenever you're watching this video. We are going to learn about some exponent product properties. So, I've got three goals here, because there are three different properties we're going to deal with. And our goals are I can multiply powers of the same base, I can simplify powers of powers, and I can simplify powers of products. So we got our 1, 2, 3 goals. And you got their superhero over there because there's so many powers here, right? Superpowers! Well, I don't know if they're superpowers, but they do some. There are some pretty sweet rules that can help you do some pretty sweet things with exponents. So the three properties we're going to deal with are the product of powers properties, the power to a power property, and the product to a power property. All right, we're going to do those one at a time. And I'm going to start you off with one general rule of thumb. This works for pretty much every situation you're dealing with exponents when you need to simplify. The rule of thumb that I'm going to give you is this. Always expand the original exponents and then rewrite them as new ones. So if you are not sure on the actual property, don't take the shortcut, write it out. So for instance, if you have x to the fifth power, rewrite that, expanded, that would be x times x times x times x times x. And if you multiply that by x to the third, let's say it was x to the third, then write that out as well, 3 more x's, and then you can rewrite that as an exponent. So we're going to talk about how that works right now, actually. So this first property, product of powers property. So think of what product means. Product means multiplication. So you're multiplying powers together. So I have two examples here. In this first example here, we have a power times a power. In our second example, we have a power times a power. So that's why it's called the product multiplication of powers property. And we're gonna just use that rule of thumb and write it out and see if we can find a shortcut, find a pattern here. So let's write out this first one. First we'll do 3 to the 4th power. That just means 3 times itself 4 times. All right, and then we're multiplying that by 3 to the 2nd power, which is times 3 times 3. Now, they're all 3's, so we can just combine them into one whole exponent, which means 3 times 3 times 3 times 3 times 3 times 3. That's 3 multiplied by itself 6 times. And there we go. 3 to the 6th power is our answer. That's how you can simplify that. Now, this only works if the bases are the same. Okay, you can't really do that if one had a base of 3 and one had a base of 20. They wouldn't work. They don't have the same base. But you see when we write it out, it actually works like this if they have the same base. Look for a pattern. See if you can see a pattern. We still have the same base. What happened with the exponents if you wanted to skip straight from this to this? See if look to see if you could find a shortcut. I don't like to cut corners, but if you can find an easier way to do something, well, there, do it. Let's whatever your shortcut is, keep it in your head. Let's look at the second one. All right, let's look at the second example. We're going to write this one out as well. So we have m to the third times m to the fourth. So let's write that out. M to the third is 3 times 3. We're not using 3's anymore. We're using m's. M times m times m. All right. M to the fourth is also multiplied there. So it's m times m times m times m. In total, if you count up, we have 1, 2, 3, 4, 5, 6, 7 m's, which, if you wanted to simplify it, would be m to the 7th power. So again, is there a shortcut to get from this to this? And if you found a shortcut on the first one, would this be the same shortcut? Well, there is. So maybe you noticed it. Here is our rule for the power. Remember, this is product of powers property. So I'll write that here. Product of powers. So, when multiplying powers with a common base, so having the same base, simply keep the base, like we did in both examples, and add together the exponents. So if you can remember this shortcut, that's awesome, because 3 to the fourth power times 3 to the second power, you keep 3 as the base, and you add 4 and 2, and you get 6 as the new exponent. It worked the same for the m's. Kept the base, and 3 plus 4 is 7. There's your new exponent. So that is the product of powers rule. And that's all I'm going to give you for the product of power rule, other than this extra little thought question here. So I want you to think about this. Can x to the 8th power times y to the 3rd power be written as one single power like we did in those examples above? And explain your reasoning. Think about it. Can it be simplified to like something to the 11th power? I don't know. That's what I'm asking. Okay? Look at the rule, look at the examples, and see if you think you could do that. And I'll show you the answer for this at the end. Next. The second property of powers that we said we're going to deal with, and this is all with multiplication, is the power to a power. Man, we got lots of power going on here. But the power to a power property means you have a power raised to a power. Okay? So I'm going to say go back to that rule of thumb. We said always expand the original exponents and then rewrite them as new ones. So how can we expand this? So this means 5 to the 4th 2 times. So we're going to rewrite this as 5 to the 4th times 5 to the 4th. Okay, now we have to expand the 5 to the 4ths. We have 5 times 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 5. And we said before, if they have the same base, we can add the exponents. So we get 8. And this actually would be 5 to the 1, 2, 3, 4, 5, 6, 7, 8. And that would be our answer. Now looking at that, I want you to think about if when you have a power, like 5 to the 4th power, raised to the 2nd power, is there a shortcut that you think, just looking at what we did, looking at the numbers, is there, again, a shortcut? Okay, whatever you think it might be, if there is one, let's try the next one. So this is x to the 5th power. So there's our power raised to the 2nd power. Okay, so we're going to rewrite this as x to the 5th power times x to the 5th power. Because when you have something raised to the 2nd power, you're just rewriting it times itself. Now we're going to simplify that. We have x to the 5th power is x times x times x times x times x. And then multiplying it by x times x times x times x times x. Or you could use the shortcut from that we learned on the last power. And you see there's a total of 10 x's, which would be x to the 10th power. So that's how you simplify that. Now again, from here to here, was there a shortcut? Well, if you found it, there is one. Here is the power to a power rule. A power raised to a power. Might be worth writing down, but when a power is raised to a power, like we had in those 2 examples, simply keep the base and multiply the exponents together. So last time when you had 2 different powers multiplied together, you added the exponents. Now when we have a power raised to a power, you multiply them together. That's the power to a power rule. Power to a power. So with that, I have another question for you. Think about this one. So it says simplify x squared raised to the 3rd power and x squared, where the 2 is raised to the 3rd power. So that's a weird one, where you have the exponent raised to an exponent. Are those 2 things equivalent? And explain. I'll show you the answer at the end, but we're going to go on to the last power, or the last property. So the final property that we're going to talk about with powers is the product to a power property. So product, again, means multiplication. So you have a multiplication problem raised to a power. So we have this right here. We'll look at our first example, and we're going to go back to a rule of thumb again. Always expand the original exponents and then rewrite them. This will work every time. So AB raised to the n power. That one's a tricky one. We're not going to actually use that one. We're going to skip that one. We'll come back to that one. Let's do this one. We'll do this one first. 3 times x raised to the 4th power. So really, you're saying you have 3x, or 3 times x, multiplied by 3 times x, multiplied by 3 times x, multiplied by 3 times x. There's 4 of those because it's raised to the 4th power. Now, if we rewrite this, where we have all the 3's in front, this would be 3 times 3 times 3 times 3, and then we have all the x's together, x times x times x times x. Because we can rewrite things, we can move things around if it's all multiplication. That's the commutative property. Things can commute. And if we rewrite this now, 3, that's 4 of them, so 3 to the 4th power times x to the 4th power. And that would be a simplified, or if you wanted to rewrite 3 to the 4th power, that's 3 times 3 is 9, times 3 is 81, or sorry, times 27, times 3 is 81. So, or it would be 81x to the 4th power. All right. Again, we're looking for patterns. We're trying to see if there's something that we can do a shortcut for this. Okay. Shortcut. Thoughts? Think about it. And let's go on to the next one. Number 2. We're going to rewrite 7m to the 9th power 3 times. This might get a little messy here. So I'm actually going to give ourselves a little bit more space. So what we have here, I'm going to write it in green, is 7m to the 9th power times 7m to the 9th power. Whoops. And then times 7m to the 9th power. So what we do, if we want to rewrite it so we have all the numbers, the common numbers together, we have 7 times 7 times 7. And then we have all the variables together is m to the 9th times m to the 9th times m to the 9th. And we know 7 times 7 times 7 is just written as 7 to the 3rd power. And we can figure out that it is 49 times 7. I think it's like 243 or something along those lines. But we'll leave it out of that for now. M to the 9th times m to the 9th times m to the 9th. That's multiplying powers together. And that's when we add the exponents. So let's use that shortcut here. We're adding those exponents. If you wanted to write it out, because it always helps to write it out, you just have 27 m's written out. So it would be m to the 27th power. And we're going to leave it at that. Because I think 7 times 7 times 7 is 243. Or we'll go with that. All right. So, again, shortcut, yes or no? Well, hopefully you found that there is one. Here's the rule for the product to a power, multiplication raised to a power. When raising a product of terms to a power, simply distribute the exponent to each term of the product in parentheses. So like this first one, if you just distribute the 4 to both of them, it'd be 3 to the 4th power and x to the 4th power, and that's what we ended up with right here. Then you can simplify it from there. The second one, if you distribute it, it's 7 to the 3rd power, which we had there, and then m to the 9th to the 3rd. And if you look back at our last property, then you just multiply the 9 by the 3, and that's where you get that. So if we did this one, back to the first one, if we distribute this, we'd have a to the nth power times b to the nth power. And we don't know what n is, so we're just going to leave it at that. Okay, so that is the rule. I'm going to leave you with one problem here to try on your own, and I'll show you the answer at the end. It just says simplify 4 times 10 to the 5th power, and that's called scientific notation. We'll learn about that soon. All raised to the 2nd power. All right, I promised I'd show you the last problems again. So if you go back to the first one, can x to the 8th power times y to the 3rd power be written as a single power? No, they cannot, because they don't have a common base. If you look at the rule, they have to have the same common base. The second one, when we're dealing with power to a power, I said simplify those two things and see if they're equivalent. But the first one, we can use that property we just did, and we get x to the sixth power, multiplying them together. And then the second one, it's x to the 2 to the third power. 2 to the third is actually 8. So this would be x to the eighth power. So no, they're not equivalent. And then finally, product to a power property. So what I did is I used this property we just used, distributed the 2 to both of them. I got 4 to the second power, and then 10 to the fifth power raised to the second power. And then I simplified 4 to the second power to 16, 10 to the fifth to the second, that would be 10 to the 10th. And I didn't simplify it any further. You can certainly do that with a calculator, but I'm not going to do that at this time. So that is the third example. And if you want to challenge yourself, I have 3 challenge problems here. If you can pause it and try them out. We will get to more like this in the future. So, finally, go back to those goals from those learning targets from this section, 3 of them, and reflect on what you learned, what you still have questions on. And I apologize for the length of the video. You can have a great rest of your day.